Hey everyone, welcome back to Astronomy Daily. I'm Anna.
And I'm Avery. And Anna, I don't think I've slept properly since Wednesday.
Because of the eclipse?
Because of the eclipse. It's Thursday, August 13th. This is Series 5, Episode 166. And yesterday, half our listeners were either standing on a beach in Spain or on a boat in Greenland watching the moon eat the sun. So yeah, today's a big one.
It really is. We've got the eclipse as our main story today, properly deep dive. We're going to spend some real time on it. And then 3 more news stories to get through. Astronomers have found 3 supermassive black holes hanging out in one single galaxy, which, rude. Virgin Galactic just pushed its comeback flight back again, and Rocket Lab's Neutron rocket is doing that thing where the deadline keeps sliding, but they're also signing new customers. So make it make sense.
Lots to get through. Let's get into it.
Okay, so let's set the scene. Yesterday, August 12th, the moon's shadow, and this shadow is about 182 miles wide, swept across the planet, starting up near Siberia, across the Arctic Ocean, down through eastern Greenland, western Iceland, northern Spain, over the Balearic Islands, and finally out into the Mediterranean.
Which is such a wild path. Like, you don't usually get Arctic Ocean and northern Spain in the same sentence for anything, let alone the same eclipse.
Right. And this is one of the reasons this one had people so excited, because it hit 2 totally different kinds of eclipse chasing experiences. You had people up in Greenland and Iceland, where it's this stark, icy, end of the world kind of landscape. And then a few hours of shadow travel later, it's crossing sunbathers in Spain.
Tell me about the Iceland leg, because I heard that's where you got the longest totality.
Yeah, so the single longest point of totality on land was at a place called Látrabjarg, which is this dramatic bird cliff on Iceland's westernmost tip. And totality there ran about 2 minutes and 18 seconds. The actual maximum point of the whole eclipse was just off the coast, about 45 kilometers out over the water.
2 minutes 18 doesn't sound like much, but when you're standing there...
It's an eternity. And this is the bit I love. One of the Space.com editors on the ground, Daisy Dobrjevic, said something like, "I knew what to expect. I've seen thousands of photos, but nothing compares to that feeling you get when you watch the sun transform before your very eyes."
That's the thing every eclipse chaser tries to explain to people who haven't seen one, and you just can't really.
There was another quote I liked from a guy watching in Spain, Anthony Wood. He said it strikes the lizard part of your brain that just tells you this shouldn't be real.
The lizard brain thing, yeah, that tracks. There's something about totality that's almost primal. Day turning to night in a couple of minutes, temperature dropping, animals going quiet.
And in Iceland, because it happened mid-afternoon, only about 4 hours before sunset, and up that far north, you got some extra atmospheric effects. This eclipse gamma geometry meant people could actually see the moon shadow moving through the high atmosphere and had this weirdly extended twilight window either side of totality.
That's very niche and very cool.
There was even a chance of aurora showing up in northern Russia if the geomagnetic activity cooperated, which total eclipse and aurora at once, that's the dream combo for a lot of skywatchers.
Okay, let's talk Spain because that's where the crowd numbers really show up.
So the path crossed A Coruña, Bilbao, Zaragoza, Valencia and Palma. Notably, Madrid and Barcelona were both just outside the path of totality. So a lot of people had to travel for it.
Which, if you live in Madrid, that's a rough one. So close, and yet, nope, you get the partial.
Millions of people gathered across small towns in northern Spain. Places like Valoria la Buena and Segur de Calafell were absolutely packed. And because it happened about an hour before sunset there, you got totality low on the horizon with this golden, dramatic lighting.
And it wasn't just a look up and go home event either. There was real science happening during totality.
Yeah, this is the bit that matters beyond the spectacle. During totality, the sun's corona, its outer atmosphere, which you basically never get to see because the sun's surface is so blindingly bright, streams out visibly into space. Observers also picked out a solar prominence, and you could see Jupiter, Mercury, and Venus all pop into the darkened sky.
4 minutes, well, 2 and a bit minutes of what does the solar system actually look like right now?
Exactly. And coronal science is genuinely useful. It helps researchers study the sun's magnetic structure and the processes that drive space weather, which is obviously very relevant right now given how active this solar cycle's been.
For anyone gutted they missed it, partial phases were visible from a huge chunk of the world too. Some are set in England, the northeastern US, Michigan, Canada, even Alaska all got a partial bite taken out of the sun.
And if you're already eclipse hungry again, Spain gets another one relatively soon, less than a year from now, on August 2nd, 2027. There's another total solar eclipse crossing Spain.
2 total eclipses in Spain within 12 months. Eclipse chasers are going to have a very good year.
They really are. So that's our deep dive, the August 12th total solar eclipse, a 182-mile-wide shadow, Arctic ice to Spanish coastline, 2 minutes 18 seconds of totality at its longest, and a genuine I can't believe what I just saw moment for millions of people.
Can we talk logistics for a second? Because I know a chunk of our listeners are already plotting the 2027 one. If you've never chased totality before, what's actually involved?
Honestly, the biggest thing is just being inside the path. Even 99% partial is nothing like totality. It's a completely different experience, so it's worth the travel. After that, it's the usual stuff: proper eclipse glasses for every phase except totality itself, a spot with a clear horizon if you can get one, and a backup location in case of cloud, because you cannot control the weather on the day.
And don't try to photograph the whole thing on your phone and forget to actually look up.
That is the classic mistake. Half the eclipse chaser community has a rule now: get 1 or 2 shots set up on a tripod and then just put the phone down and watch it with your own eyes, because you only get 2 minutes and 18 seconds and you don't get them back.
I did see the live streams were huge for this one too. Between the Greenland boat expeditions and the Spanish coverage, there were millions of people watching online who couldn't be there in person.
Which is honestly one of the nicer things about how big eclipse broadcasting has gotten. You don't have to be a hardcore chaser with a passport full of stamps to get at least some of the I can't believe what I just saw feeling.
Still not the same as the lizard brain moment though.
No, nothing beats being there. But August 2nd, 2027 in Spain is looking very tempting for a lot of people right now.
All right, from 1 sun to 3 black holes. Astronomers have confirmed, for the first time, 3 actively feeding supermassive black holes sitting inside a single galaxy.
Which is just greedy.
The galaxy is called J01484214, and it's about 12.5 billion light years away. So we're seeing it as it looked roughly 1.2 billion years after the Big Bang.
So this is baby picture of the universe stuff.
Exactly, and that's what makes it such a big deal. The team, led by Hannah Ubler at the Max Planck Institute for Extraterrestrial Physics, used the James Webb Telescope's NIRSP instrument to find them. Specifically, a technique called spectroastrometry, which measures tiny spatial shifts in the light coming from hydrogen emission to pin down exactly where each black hole is sitting, even though they're really close together on the sky.
And these aren't small either.
No, roughly 80 million, 2 million, and 0.6 million solar masses. And here's the kicker: 2 of the 3 are on a collision course. They're heading for a merger.
So why does finding 3 in one galaxy actually matter scientifically? Beyond just, wow, 3.
Because it's evidence for how supermassive black holes get so big so fast in the early universe, which has honestly been a bit of a puzzle. If black holes can merge with each other, not just grow by slowly swallowing gas, that gives them a much faster route to becoming supermassive. Ubler's team is essentially saying mergers might be doing a lot more of the heavy lifting early on than we thought.
It's basically a black hole growth hack, cosmic speedrunning to supermassive status. But it does reshape how we think about galaxy assembly in the early universe. If triple black hole systems like this aren't a total fluke, there could be a lot more of these hiding out there, waiting for JWST to spot them.
For scale, Sagittarius A star, our own galaxy's black hole, is about 4 million solar masses.
So the biggest of these three, at 80 million, is 20 times heavier than the black hole sitting at the center of the Milky Way.
And that's just one of three in the same galaxy.
Right, which tells you this galaxy was doing some serious growing up fast. It's another one of those results where JWST just keeps outperforming what Hubble could ever have shown us at these distances. This is a level of detail on a 12.5 billion-year-old galaxy that simply wasn't accessible a few years ago.
JWST really is the gift that keeps on giving. We'll be watching to see if Uber's team or anyone else turns up more of these triple systems now that people know what to look for. Sticking with things that are taking longer than planned, Virgin Galactic has delayed its return to commercial spaceflight. Again.
Again being the key word.
Right. So the new spacecraft, this is their upgraded Delta-class vehicle, was supposed to start flying paying customers in the fourth quarter of this year. That's now been pushed to February 2027.
What's the holdup this time? According to the company, it's avionics and systems installation on the first operational spacecraft. They say they need more time to get it right before putting people on board, which, fair enough. I'd rather they take the extra months than rush it.
Always the right call with anything crewed. How did the market react?
Not well. Shares dropped about 12% in after-hours trading on the news.
Ouch. But there's a more interesting story buried in the same filing. Their $750,000 a seat flight packages were oversubscribed, and CEO Michael Coglazier said they'll be offering higher price points when ticket sales reopen this autumn.
So even with the delay, demand isn't the problem. If anything, they could be underpricing seats.
Seems that way. Financially, the picture is actually improving too. Net loss narrowed to about $56 million, down from $67 million a year ago. And they've still got $286 million in cash and securities on hand.
So they can absorb another delay. They've just got to actually get the Delta ships flying at some point.
That's the whole story with Virgin Galactic at this point, isn't it? The money and the demand are there. It's the hardware timeline that keeps slipping.
It's a very different position than where they were even 5 years ago, right? Back when this was Richard Branson's company flying the original Spaceship Two on short hops. And everyone was comparing them directly to Blue Origin's New Shepard.
Right, and that comparison's aged in an interesting way. Blue Origin's had its own well-documented hardware problems this year too, so it's not like Virgin Galactic's the only one whose timeline keeps slipping. Suborbital space tourism as a whole seems to be harder than everyone hoped across the board.
Which, building crewed spacecraft's always harder than everyone hoped. We'll check back in as February 2027 gets closer. Last one, Rocket Lab. Their new medium-lift rocket, Neutron, is looking less and less likely to make its planned debut before the end of this year.
How much of a slip are we talking?
The company's now hedging pretty openly. This could push out of 2026 and into 2027. It's the kind of narrowing window language that usually means don't hold your breath for December.
Rocket development timelines name a more consistent disappointment.
Honestly. But, and this is the fun contrast, in the same window, they announced a brand new 5-launch deal with Kepler Communications, who will be flying payloads on Neutron once it does get off the ground.
So customers are still betting on it even as the debut date wobbles.
Exactly. And Rocket Lab's actually coming off a record revenue quarter, so the business overall is healthy. It's specifically Neutron's first flight that keeps sliding, right?
Which, to be fair, is basically the story of every new orbital rocket ever built. Starship slipped for years, New Glenn slipped for years.
Ariane 6 slipped for years.
Right, it's basically tradition at this point. We'll keep you posted on Neutron as we get closer to an actual launch date.
For anyone not fully across it, Neutron's the reusable medium-lift rocket Rocket Lab's been building to sit between their small Electron rocket and the big players, basically going head-to-head with Falcon 9 for the medium payload market.
Which is a pretty crowded lane to be entering late. Falcon 9's flying constantly, and everyone from Blue Origin to the Chinese commercial players wants a piece of that market too.
Exactly why deals like the Kepler Communications one matter so much right now. Signing customers ahead of your first flight is basically a vote of confidence that Rocket Lab's execution track record with Electron is enough to earn trust, even with Neutron itself still on the ground.
Reputation doing some of the heavy lifting while the hardware catches up. Okay, that's our stories for today. Quick recap, the total solar eclipse over Greenland, Iceland, and Spain gave millions of people a lizard brain moment on August 12th. Astronomers found 3 supermassive black holes cozying up in one distant galaxy, 2 of them headed for a merger. Virgin Galactic's Delta-class comeback flight has slipped to February 2027, and Rocket Lab's Neutron rocket is picking up customers faster than it's picking up a launch date.
If you enjoyed today's episode, the best thing you can do for us is leave a rating or review wherever you're listening, and share the episode with a fellow space nerd. You can find full show notes, sources, and links for every story we covered today at astronomydaily.io. And find us on social media. We're at Astronomy Daily Pod pretty much everywhere.
We'll be back tomorrow with another episode. Until then, keep looking up.
See you next time.